Okay, so as we continue with our equations and inequalities, we're going to talk about the absolute value equation. And we need to remember that an absolute value is an example of one of our mathematical concepts which can't be defined using just one condition. And that is because we know that the absolute value is our distance from zero. So if we're looking for the absolute value of 2, the absolute value of 2, I'm sorry, the absolute value of, we use that. Absolute value of 2 is 2 because I am 2 away from 0, and the absolute value of negative 2 is 2 because I am 2 units away from 0. So again, the absolute value is distance. It's the distance from 0. That's why it always represents a positive number. And then those brackets in an inequality, the absolute value brackets in an inequality or equation, they represent those two different conditions. So we have to clarify those conditions to satisfy and write our equations to represent that. And algebraically, we'll talk about it in a little bit, but we know that the absolute value of x is x. But we're going to learn about the negative value of that, and we could have a negative x. So again, we will work with this in class a lot, and we just want to be prepared for it. So as I talk about what are my solving an absolute value equation, and we want to be able to solve equations and inequalities with absolute values. What is the solution of the equation in graph, and check the solution. So you want to remember that when we have absolute value equations, we want to first solve, our first steps in solving is to isolate the absolute value expression. If necessary, then writing it as an equivalent pair of equations or inequalities, and we'll practice with that. So we know here in A that if we're going to isolate this, we need to move in order to isolate our absolute value, we are going to have to subtract 2 from each side. And we then know that the absolute value of x is going to be 7. So we know that the absolute value of x is 7. Well, we know that there are two possible answers to that, and we have x could be negative 7 or x could be 7, because both negative 7 and 7 are 7 units away from 0. And here is my number line. So we have 2, 4, 6, 7. So we have negative 7 is 7 units away. And then we have 2, 4, 6, 7. 7 is 7 units away from 0. So that's why we have both a positive and a negative answer. And you can substitute it back in to check it. If we do that, we have the absolute value of negative 7 is going to be 7, and the absolute value of 7 will be 7. Again, absolute value, the quantities within inside the absolute value will simplify to a positive value. Let's see here, going to the next example. Now this one can be tricky. It's not intended to be tricky, but we want to find the absolute value of n minus 5 is equal to negative 2. So if we do that, let's see here, we know that the absolute value of n, the absolute value of n minus 5 is equal to negative 2. Add 5 to both sides, and then we have 3. So the absolute value of n is equal to 3. So we know that n could be negative 3 or n could be 3, because both 3 and negative 3 are 3 units away from 0. So on my number line, 1, 2, 3, 1, 2, 3. And then we can see here that, again, negative 3 is 3 units away. Positive 3 is 3 units away. So there we have it. Now, if we start talking about distance, and distance is inherently a positive number, because even if you step backwards, you've traveled distance. It doesn't mean that it's in reverse. It means that you just went a different direction. So looking here at this example, all right, so we are starting 100 feet away. Your friend skates towards you and then passes by you. He skates at a constant speed of 30 feet per second. Her distance, d from you, in feet after t seconds is given by the equation, and it looks like it has been divided up here by the return, is going to be d equals the absolute value of 100 minus 20t. And then what are the times, at what times is she 40 feet away from you? Okay, so we are looking for, before I think about anything, they want me to find at what times is she 40 feet away from you. So I'm looking for what time, and then the distance that they're giving me is going to be 40 feet. So we have what time, let's see here, this equation. So we can set this equation up and we can do some substitution. So we know that the absolute value here, what we have within the absolute value sign, could be a positive value or a negative value. So we can go ahead and do some substitution here. So we are looking for 40 feet, and that is going to be my d value. So I can go ahead and substitute that in. So I'm going to have 40 equals the absolute value of 100 minus 20t. And we know that t stands for seconds, and I substituted in d, which was 40. And then I know, again, what I was trying to say is that everything within here could be a positive or negative number, because when we find the absolute value of it, it will become positive. So we will set this up as the absolute value of 100 minus 20t is equal to 40, or the absolute value of 100 minus 20t could also equal negative 40. So in doing so, now we can solve these two inequalities. We can solve these two absolute value problems now that we have split it up into two independent problems. We can go ahead and do the ciphering, as Jethro Bodine would have said. So solving the problem on the left first, we're going to go ahead and do some isolation, isolating our variable. So we're going to have negative 20t is going to be equal to negative 60. Divide both sides by negative 20, our coefficient. And then t is going to be equal to 3. And then if we do our other equation, we are going to have 100. Go ahead and subtract our 100 from both sides. And we're going to have negative 20t is equal to negative 140. Divide, again, both sides by my coefficient. And then we are going to have t is going to be equal to 7. So the time now, the time that your friend is d distance away from you, which is going to be 40 feet, at what times is she 40 feet from you? It is going to be when my time is 3 seconds and 7 seconds. So again, 3 and 7 seconds. We're always worried about context. There you go. And let's see here, we can probably do this next one here. Another friend's distance from you in feet after t seconds is given by this equation. And then what does the 80 in the equation represent? And then what does the 5 in the equation represent? And at what times is she 60 feet from you? Okay, well, we know that d is going to be the distance. And then it asks me, what does 80 represent? And if we go back and we look in the previous question, we started off 100 feet away, and then in my equation, it said she was moving towards me, so it looks like we were 100 feet away, and she was moving towards me at 20 feet per second, because there's a subtraction sign there, which means our distance was decreasing, so she had to be moving towards me. So if I look at that in this example here, that we are starting 80 feet away, and minus 5t. Well, that tells me that she is moving towards me at 5 feet per second, because each second the distance between us is decreasing, so she must be moving towards me. And then the 5, what does the 5 represent? Well, that must mean how fast or how far she is traveling per second. And she is traveling 5 feet per second. So when we go to set this equation up, we're going to do the same thing we did before. We have been given a 60 feet from us. What times is she 60 feet? So I'm going to replace D with 60. So I'm going to have 60 is equal to the absolute value of 80 minus 5t. And then I know that when I split that up, that value could be both positive and negative. So I am going to have 60 equals 80 minus 5t, or negative 60 equals 80 minus 5t. And now I'm just going to solve these problems independently. Okay, so I've gone and solved these, and you can look them over, but I know that 60 equals 80 minus 5t. I go ahead and combine like terms, move my numbers over to the left, inverse operations, and I subtract 80 from both sides. So I'm going to have negative 20 is equal to negative 5t, and then divide both sides by the coefficient, and then I'm going to have t is equal to negative 20 divided by negative 5, which is going to give me 4, and that means at time is 4 seconds. And then my first input, or my first step here on this other side, as negative 60 equals 80 minus 5t, subtract 80 from both sides, I have negative 140 is equal to negative 5t. Divide both sides by the coefficient, which is negative 5, and then t is going to be equal to 28, or t is equal to 28 seconds. So there you have it. That's how we're able to figure out that absolute value. We're going to talk about here. Okay, so looking at the absolute value of 8n is greater than or equal to 24, well, we're going to be looking at this, and we're going to realize that we can also have some negative values in here. So the absolute value of 8n is greater than or equal to negative 4. It is also going to be less than or equal to a negative 24. And as we graph this, it'll be a little bit more evident, but if we take this independently and we go ahead and do our inverse operations, divide by 8, then we're going to have n is going to be greater than or equal to 24 divided by 8, which is 3. Or it's going to be, again, dividing by the coefficient, n is going to be less than or equal to negative 24 divided by 8, which is going to be negative 3. Now, when we go to graph that, just looking at this first inequality, before we were to change anything, we said that n is going to be greater than or equal to 3, which on my number line is right there. And we are how many units away? We are going to be 3 units away from 0, and it is greater than or equal to, so it is going to continue to enlarge and go positively, keep continuing on to positive infinity. Well, the next one is going to be n is less than or equal to negative 3. Well, there's my negative 3, and less than or equal to is going to be shaded to my left, going to positive negative infinity. So, and if you look, we are going to be 1, 2, 3 units away, and we are going to continue to move away from 0. On the positive inequality, we're 1, 2, 3 units away, and we are going to continue to move away from 0. So there you have it graphically and algebraically, what we're looking at. Moving on to this next one, what are the solutions of the absolute value of 2x plus 4 is greater than or equal to 5? Well, doing what we've just done, we know that 2x plus 4 is going to be greater than or equal to 5. Or we know that 2x plus 4 is going to be less than or equal to negative 5. Now, if we go ahead and do some solving, solve each one of these independently, doing your inverse operations to isolate your variable. And we're going to end up with x is greater than or equal to 1/2. And again, I subtracted 4 from both sides to isolate my variable term. Then I combined like terms, and then I ended up with 2x is greater than or equal to 1, divide by the coefficient on both sides, and I have x is greater than or equal to 1/2. Moving over to my other problem, the second half of this problem, I go ahead and combine like terms, moving 4 over to the other side, and I have 2x is less than or equal to negative 9. Divide both sides by my coefficient, and then x is going to be less than or equal to, negative 9/2, and we also know that as negative 4.5. So as we go to put that on a number line, when I graph that, okay, so as I go to graph that, we know that x is less than or equal to negative 4.5, so that is going to put me somewhere in between 4 and 5, so halfway between 4 and 5 is going to be negative 4.5 is going to be included, so it's a closed circle, and less than or equal to will move me to negative infinity. And then the next answer is going to be x is greater than or equal to 1/2, and that is going to put me about right here, which is in between 0 and 1. So greater than or equal to 1/2, moving towards positive infinity. So there you go. There we have it graphed. We came up with our two solutions, and that is working with inequalities. So now applying what we're trying to learn with absolute value, a company makes boxes of crackers that should weigh 213 grams. A quality control inspector randomly selects boxes to weigh. Any box that varies from the weight by more than 5 grams is sent back. What is the range of allowable weights for the box of crackers? Well, we know that we have this difference between the actual and the ideal. Difference between the actual and the ideal weight, and it can be at most 5 grams. So at most we are looking for a less than or equal to 5, and we know that we're going to have this absolute value of a weight minus the ideal weight, which was 213. So there you go, the difference between the actual and the ideal. So we have the actual, which is what we weigh, minus the ideal weight, which is identified in the problem, and it has to be less than or equal to 5 grams. That's all the difference that we can have, otherwise they send it back, wasting too much money, wasting too much product, decreasing the profit. So when I solve this, now I've come up with the absolute value equation. I go ahead and solve it just like I did before. We know then that W minus 23 is going to be less than or equal to 5, or W minus 213. W minus 213 is going to be greater than or equal to negative 5. So doing my inverse operations over here on the left problem first, not that it matters which one we choose first. I'm going to go ahead and add 213 to both sides, and that is going to give me then less than or equal to, on this side is going to be 218. So W has to be less than or equal to 218. Doing my inverse operations on the other side, W has to be greater than or equal to 208. So there you have it. Does it ask us to graph it? No. So we know then that W, the weight, has to be greater than, has to be less than or equal to 218, but greater than or equal to 208. So there we go. For all values of W, W should be less than 218, but greater than 208. Okay, so looking at this next problem, we have food manufacturer makes 32 ounce boxes of pasta. Not every box weighs exactly 32 ounces, imagine that. The allowable difference for the ideal weight is at most 0.05 ounces. At most, right? Can't be any more than 0.05 ounces. And write and solve an absolute value inequality to find the range. Well, we just said that the absolute value is going to be the actual minus the ideal, and then, of course, our allowable difference. So now we can go ahead and separate our problem. So we have W minus 32 is less than or equal to 0.5, or W minus 32 is greater than or equal to negative 0.05. 0.05, sorry. Making some mistakes here. It's getting late. So go ahead and do my inverse operations and solve independently for both one of these inequalities. So adding 32 to both sides, W is going to be less than or equal to, let's see here, that should be 32.05, or adding 32 to both sides, W is going to be greater than or equal to 31.95. So again, W is less than or equal to 32.05, or greater than or equal to 31.95, and remember that is ounces. And that is our writing. We wrote a absolute value inequality. We were able to solve and find the allowable ranges of weights for those products. Now, just useful, we were able to practice the mechanics of it, apply it, use it, and just understanding that many of these problems are intended to, you think, why does it matter if we weigh a little bit more, a little bit less? Well, the quality control would be that if, in this case, if I'm creating a box of crackers that weighs too much, I may have to pay extra shipping to ship it to somebody. Or if the boxes are too light, a customer may be unhappy with the product because they're not getting what they feel is the value that they paid for. So this is all quality control and making sure that you stay within your allowable limits. Just imagine trying to make a recipe and you didn't use the right amount of flour. Your cake might not turn out properly. So there's an allowable limit in which you can adjust that recipe. So again, absolute value allows us to apply and find our limits.